All right, let's get started. Okay, welcome everyone. I'm going to talk about building NFTs on Bitcoin, which might sound a little strange because like how can you enable something like this, smart contracts on Bitcoin? That's what we're going to talk about today, and we're going to see if we can get this done in 1 hour. So I'm going to run you through building it, but also deploying it. So I'm going to assume that you know a little bit about smart contract engineering. So you maybe have done some Solidity or you used Truffle or something like that. Otherwise, since this is recorded, you can always go through at your own pace and check it out again. So NFTs on Bitcoin, how does that work? Well, before I get into that, I'll do a quick intro on myself. So my name is Marvin Jensen. I'm the technical lead at an organization called the Stax Foundation. So that's stax.org. So before we get into that, so what is Stax? So Stax is a layer 1 blockchain that is connected to Bitcoin. So some people have heard of Stax before, and they think that it's sort of like a side chain or it's merged mined or something like that. But this is not the case. So it is its own layer 1 blockchain, but it has a unique consensus mechanism called proof of transfer, which anchors it to Bitcoin. So what this means in short is that with the consensus mechanism, the finality of the state is reached on Bitcoin itself. So this takes the form of sending a transaction on the Bitcoin chain, and once that transaction is mined, finality is reached. The reason for this is that it allows Stax to leverage the security and resilience of Bitcoin while enabling more features and smart contract capabilities. So we won't have enough time to really dive into proof of transfer, but I invite you to check it out and read the white paper. But basically, it means that you can have a large number of transactions on the Stax chain secured and encoded by a single transaction on the Bitcoin chain, it's very unique. So the proof of transfer comes in where in order to be eligible as a leader to create the next block on Stax, you have to spend the base token, which in this case is Bitcoin. So Stax miners, they have to spend Bitcoin, so they have to spend something of value in order to be able to mine the next block. So that's why it's called proof of transfer. But again, like a deep dive, maybe that's something for a future session. So on Stax, we have a new smart contract language called Clarity. And Clarity is a little different from other languages, which I'll get to in a little bit. But these smart contracts that you build on Stax have direct read access to the Bitcoin chain. So you can actually build triggers based on something that happens on the Bitcoin chain. So we've seen this translated into a number of different things already. And just recently, another developer in the ecosystem called Friedker made the first Bitcoin swaps. So where you can submit a Bitcoin transaction to a Clarity contract, which triggers a swap of, say, an NFT or something else. So you can use actual real Bitcoin. So this is not a wrapped Bitcoin or anything, but you can use a real Bitcoin to purchase an NFT that is secured by Stax, which is very, very interesting. Okay, so let's talk a little bit about Clarity. Again, we'll go over this briefly because I just want to jump straight in and get writing a Clarity smart contract ourselves. So as I said, it's a little different from the other smart contract languages out there, in particular Solidity. So I'm sure most of you have done some Solidity before, and this comes with certain caveats and certain things that you have to think about. So compared to Clarity, Clarity is an interpreted language. It's not compiled. So you all know that if you do something in Solidity, you use something like Truffle or something else, which will invoke the Solidity compiler, which turns this into EVM bytecode. And that is what is posted to the Ethereum chain, right? So there's an extra step in between. And this bytecode is something that, well, I think for most people, it's not very easy to read. So you've seen, honeypot smart contracts or different trickery going on where you send a transaction on chain, but the contract you're sending it to is actually not readable, right? You go on Etherscan, you can't read, you can't see what's going on. So that's not the case with Clarity. So Clarity is interpreted, which means that the code you write is exactly the code that you're going to post on chain. So anyone can verify this. You can imagine like everything on Stax is open source. So why is it done this way? Because arguably in interpreted language, you need more storage space to be able to actually save that instead of compiling it to a more optimized bytecode language, if you will. And that's very simple. So I would ask all of you the question, would you sign a contract you cannot read? So I'm talking about just the real world, not the crypto space, but you go to a bank, you go anywhere at all, and they hand you a contract in a foreign language. Like, who would feel comfortable signing that contract? I don't think anyone would. So why would it be any different when it comes to crypto? Why would you commit your tokens to a contract you can't read? You don't know what it's going to do. So that's why Clarity is interpreted. Then there's a few other properties, which I'll go over quickly. So Clarity is a decidable, non-Turing complete language, which means that it doesn't have things like possibly infinite for loops and other structures like that. So the upside to that is that when you execute a Clarity function, you know with absolute certainty that it's going to end at some point. The execution is going to halt. So this gives the nice feature that when you send a transaction on the Stax chain and you call into a contract, that the node can statically analyze the entire call graph. So it knows exactly what the most gas it's ever going to use, or what the most gas would be. So you don't need to figure out things like gas estimations. There's no issue with like running out of gas or something like that, because it knows exactly beforehand like how much gas it's going to use. So decidability comes with a few trade-offs. As I said, there's no for loop, so you have to design your contracts a little differently. But be very curious to see if there would be something that you could do on Solidity that you cannot do on Clarity, because even with Solidity, it being Turing complete, you do have an upper bound, a limit of what you can do, which is defined by the amount of gas that you can spend on it, right? Clarity does not permit reentrancy. So you've all heard of reentrancy bugs, where a contract calls into a different contract and then it calls back into the original contract, and this can trigger some sort of glitch. Like you can drain tokens before the balance sheet was updated, things like that. Clarity just does not permit reentrancy by design. So if that happens, the transaction is automatically reverted. You don't have to build reentrancy guards and things like that. Just the same. So overflows and underflows are not allowed in Clarity. If you try to do that, or if that happens by mistake, it automatically throws a runtime error and it exits. So that's very nice. You don't get those weird glitches where you can subtract a small amount and it goes into the negatives, but it's an unsigned integer, so it flips around and becomes a huge number, and suddenly you have an amazingly large balance. There's no possibility for that in Clarity. Another one, which is what we're going to use today, is that it has support for custom tokens built in. So, Ethereum pioneered a lot of these interesting standards like ERC20s and ERC721s. With Clarity, we have built-in functions that do that for you. So you can just define a new NFT and you can transfer those, and it gives you all the proper guards. So it protects you against those overflows. It protects you against a supply increase beyond the maximum supply and all those things. Then another feature of the Stax chain is called postconditions. So these allow you to assert that the chain state is a certain way at the end of a transaction. So in simple terms, that means that if you do a contract call, you have to attach a post condition to your transaction that says, at the end of this contract call, I will have spent exactly 500 Stax tokens. And that gives the contract only the ability to use exactly that much. So it will protect the user against smart contracts that try to do something nefarious. And since custom tokens are built in, post conditions can also be used for NFTs and for fungible tokens. So if you are trying to trade on, say, a decentralized marketplace, you want to sell your NFT, you will have a post condition that says, at the end of this transaction, I will have transferred this NFT from my address to a different address, which is very, very powerful. Finally, response codes have to be checked in Clarity. So, it has happened more than once in Solidity where you do a low-level contract call from one contract to another, but you forget to actually check the return status. So the contract that was called, might have reverted, but you did not check if that was actually the case, and then you continue. So you think that something has happened when it really hasn't. Easiest example for that is, again, simple marketplace. You call into a ERC20 contract and you say, okay, transfer this many tokens from user A to user B, but that call fails and you forget to actually check if the call had succeeded. And then you continue on and you update your balance sheet and everything runs amok. Very, very bad. So Clarity does not allow you to do that. So if there's a function that returns a response type, so either it has succeeded or it failed, you have to deal with that response. You cannot ignore it. Otherwise, you cannot even deploy the contract. The contract will just be invalid. Okay, so that's a very quick rundown. I do want to open it up for maybe questions for just a few minutes before we move on. So if anyone wants to, if anyone has any questions, feel free to post it in chat, and we'll discuss those, and we'll have at most 5 minutes for this because I do want to move on. So any questions on this? And I know this was a lot of information in only a few minutes of time, but I want to set the stage for when we move on to Clarity itself.
I'm trying to see some syntax. Maybe that'll like open up some more questions.
Yeah, I think we'll do another round of questions after this session. Appreciate that. Okay, so let's just jump in. All right. I assume that everyone can just see this editor right now.
Yeah, we see VS Code.
Cool. Okay, so I think the best way we can do this is also readable for everyone. So is the text large enough? Okay, I assume it is. Thank you very much. Okay, so since we only have about 40 minutes left, I think the way we can do this is I'll just talk through this. And if you have a quick question, just feel free to pop that in chat. And then otherwise, we can have a round of questions at the end. And again, you'll have the recording to use later if you want to try this out yourself. Okay, so I'm going to use Visual Studio Code, but you could obviously use anything you like. So for those that have done Ethereum development before, you know that probably you're using Truffle or you're using Hard Hat to do your development. So on Clarity, we have a tool which I really like the name. It's called Clarinet, which takes it's the equivalent, I should say, actually. It's the equivalent of Truffle and Ganache. So for those of you that have never heard of those terms before, Ganache is like an application to easily run a local Ethereum chain, and then Truffle is a development tool that allows you to deploy and test your contracts and things like that. Like, it actually helps with your project. So we have one tool for that called Clarinet, which can both manage your project, but also test it and run a local chain, a local Stax chain, if you will. So we're going to use Clarinet, and we're going to create a new project by saying Clarinet new, and let's call this my NFT. So it's going to create a bunch of directories, as you can see up here, and that's what we're going to be working from today. So I can show you access here. There's a few different files. Okay, so I told you that with Clarity, we have built-in functions to manage NFTs and manage fungible tokens. But that's all there is to it. So it just defines the functions. It doesn't define the standards. So by standard, I mean, like ERC20 pioneered fungible tokens, ERC 721 pioneered NFTs, right? So on Stax, we have a similar proposal mechanism that we just called SIPs, so Stacks Improvement Proposals. And I'll show you the one that we'll be working with today. So SIP 9 is the definition for non-fungible tokens on Stacks. So this was formulated by Friedger and Muneeb and signed off by Jude Nelson. So you can find all these SIPs in its own repository on the Stax.gov organization. So I won't go through the whole specification because I'm sure that you guys know what NFTs are. So the important bit here is the NFT trade that we see right here. We're going to copy this to a project. So I'll do that first, and then we'll talk about what a trade actually is. So let me just grab that here. And I will create a new contract file for this trade. So I'm going to say Clarinet contract new, and I'll just say NFT-trade. And it'll create two files for me. So in the contracts folder right here, I now have this file. So I'm going to paste the trade in here. The other thing it generated was a test file. So you can write unit tests for Cloudy smart contracts in TypeScript. This might be very good news for some people. But we'll delete this file right now because we don't need to test this trade. Okay, so I just copied this trade from the SIP document. So an NFT trade is a little bit like a template, I should say, a template that defines the public interface of a contract. So to again compare it with Solidity, and Solidity, they use an inheritance-based model, right? A contract is like a class, and you can create subcontracts that inherit the base contract, right? So you get like a class chain with contracts that then have different properties. So this can lead to very complicated designs with implicit behaviors. So Clarity doesn't follow that paradigm. Instead, in Clarity, it uses composition over inheritance. So composition means that you put different things together to form a complex contract, and you don't have an inheritance model. So this allows for greater flexibility and also allows for contracts to have partial features of one thing or another thing. So the NFT trade then just defines all the public functions with the input types and the output types that the contract should have. So for the NFT trade, we have a function called get last token ID, get token URI, get owner, and transfer. You see that we have a lot of brackets here. So that looks very curious. We'll get to that once we start creating our own contract here. So the way to read this is that these are the input types and then these are the output types. So in short, this just means that this function has no inputs and the output type is a type response that will either have a number if it goes well or a number if it doesn't go well. If you don't know what this means, we'll get to this too. Then there's another function, get token URI, where you pass in a number and then you get a response. You get owner, you have to pass in a number, you get a response, and then a transfer function, you pass in a number and a principal and another principal, and then you get a response. So what is a principal? So a principal is basically what an address is in Ethereum. So a principal can either be a standard principal, which is one that is backed by a wallet, right? So you have a private key and you send a transaction. So your public address, we call that a principal. A principal can also be a smart contract address, so then it would be a contract principal. Okay, so we'll see how this goes together as we create our own NFT. So I'm going to say Clarinet new, Clarinet contract new. And I'm going to create a NFT called Marvin token. I think that sounds pretty good. Okay. So what's going on here? Okay, sorry about that. So I used Clarinet contract new Marvin token to create a new token contract right here. And I'll start with just a basic expression that we'll discuss again near the end. So when we talk about trades again, that is going to refer to the trade that I just created, and is going to assert that it implements this particular trade. So this trade is called NFT trade, which is in a contract called NFT trade. So I spell that out as NFT trade.NFT trade. So we're just going to leave that as is for now, this relation. I'll also add it in here actually. So the Clarinet.toml file is a configuration file that specifies all the different contracts that you have in your project, and it also specifies the relation between these contracts. So you can see that I have my NFT trade right here and the path to the file, and I have Marvin token right here. And then there's a section called depends on, and here I can specify the dependency graph. So since Marvin token depends on NFT trade, I will enter it here. So what this does is it ensures that Marvin token is deployed before, that the NFT trade is deployed before Marvin token is deployed, because otherwise, since it depends on it, that wouldn't work. I see a quick question. I got comments built in. That's what up. Can this be auto-populated based on imports in the TOML file? Tristan, could you specify what you mean by can this be populated? Like, what's this? You mean the generation of this implement trade statement?
Yeah, I think it's asking if that, like, do we have to manually do it every time, all the dependencies, or is there a way to do it from those statements where it just knows how it just generates a graph for you?
Yeah, that's actually a great question, and yes, this was actually added to the latest version of Clarinet, so it will automatically figure out the dependency graph. Yeah. Okay, so let's jump into actually writing this contract. Okay, so as you've already seen here, Clarity looks a little bit different from probably most languages that you're used to. So compare this to Solidity, compare this to JavaScript or TypeScript or something like that. This looks a little bit different. And that's because Clarity is a Lisp-like language. You might have heard of Lisp before, maybe you've done it before. I'm not sure. It's becoming a bit more popular thing, but Lisp is really the easiest way to explain this is it's lists within lists within lists. So you get to see patterns where you have certain expressions, and these are all embedded in lists themselves. So every single one of these, we can refer to an expression. So there's one expression here that contains another expression here and another expression, right? So that's what Lisp is. The reason for this choice, I think, is because it allows for easier analysis of the language. But for the other reasons, we'd have to ask the language designers. But I would say, once you get used to this, it's there's a beauty in its simplicity, because there is no difference, no distinction between code and data. They follow the same structures, which is very nice. Okay, so I'm just going to jump straight in, and then you'll see how everything goes together here. So we talked about this get last token ID. That's the first function that we have to define. Now, if you just look at this, and if I give this trait to someone, it's a little hard to guess what is actually going on, right? So we have the zip available to us here that explains what all these functions are supposed to do. So right here, we have last token ID, right? It takes no argument and returns the identifier of the last NFT registered using the contract. So it's very similar to an ERC 721, right? Where you get the last token ID has been defined. So let's just start with that. So I'm going to write this function, and then we're going to take a look at it together. So I'm going to write get last token ID. And then here there's a body. And that's going to look like this. So you can see right here that defining a function in Clarity takes the form as its own function call. So there is a built-in function called define read only, which will define a read only function. So read only function is, well, just like a view function, you know, in Solidity, where you can read chain state, but you cannot update chain state. So read only function is therefore cheaper and easier to call, but also on Stax, it allows you to call this function without actually sending a transaction. So you can call into this and you can get this information without actually having to spend a fee on calling this function. So since it talks about a last token ID, that's something that we'll have to define as a variable. So we have an incrementing number that will stand for our unique token ID, right? So this is very, very similar to ERC 721. So these built-in functions that make it very easy for us to define an NFT. So you can see there's a function called define non-fungible token. We have to give this NFT a name. So I call this Marvin token. And then we have to specify an identifier type. So with ERC 721, the type is always an incrementing number, basically. But in Clarity, you can choose any sort of identifier type, which will become the unique identifier for these NFTs. So for example, if you're building a naming system, right, you could have an identifier type that is based on a string, so that, you know, you pass in the string Marvin, and this is then its own NFT with exactly that identifier. So that opens up a lot of new unique possibilities, I think. But since we're implementing this trait, and the trait specifies that we should deal with unsigned integers, that's what we're going to specify here. So we say define non-fungible token, Marvin token, which is identified by a uint. That's a good question. If the identifier already exists, so we were going to get to this, but let's just put this in right now. So we can do NFT mint, another built-in function, where you can say asset name, asset identifier, and then recipient. So we can do Marvin token. The asset identifier could be, you know, the first one. So we say U1, and then the recipient would be me or the contract deployer. So we can say TX sender. So this will mint a new Marvin token with an ID of U1 for the person deploying the token, deploying the contract. So if I try to do this again, then the NFT mint function will fail, because it has built-in guards to deal with that. So let's see if I can pull that up real quick here. We are a little bit pressed for time, so I won't, I'll give you this reference at the end as well. But just to show you, so here's the documentation page for NFT mint. So NFT mint instantiates an asset, but if the asset identified by that asset identifier already exists, then the function will return a error response with the code U1. And then otherwise, if it successfully mints, it'll give you an OK true. So that means that this second call right here would fail to mint that actual token, because U1 already exists and it's already owned by the transaction sender. Yeah, that's a great question. And this will check the public blockchain locally. So it checks based on where the contract is running. So if you deploy this on mainnet, then obviously it's going to check that on mainnet. But if you're running this locally on a test chain that you reset, then, you know, every time that chain state is reset as well, right? Okay, so that's NFT mint. And then we have a few other functions that we're going to take a look at. So if I type NFT, you can see that we have an NFT transfer, we have an NFT get owner, and then we have an NFT burn to destroy tokens. Right? So we'll get to this in a bit then. Okay, so now that we know, let's actually bring this back. Now we know how to mint a token. The issue here is this U1. So unsigned integers are always prefixed with a U in Clarity. And this is just to create a visual distinction that you're talking about an unsigned integer as opposed to a signed integer. So an unsigned integer can be 0 or a positive number. A signed integer can also be a negative number, right? you can have lots of issues if you mix up the sign of your numbers. But in Clarity, you have to prefix that with a U and it will check that for you. Okay, so what we'll do is let's turn this minting function here into its own test function, if you will. So I'm going to define a new public function that I'll just call mint. And in the body, I will put that mint call right here. So that later when we're going to test this out, we can call into this function and it will mint a Marvin token with U1 for the transaction sender, and we can test that out. Okay. So what we're going to do now is figure out a way to implement this get last token ID, and this should return the uint of the last NFT that was minted. So the easiest way to do that is just to define a variable. In Clarity, you do that with define data var that we can call just last token ID. The type is going to be uint, and the initial value is going to be u0. Then all we have to do in this function here is a var get. So we read this variable and we return it. So we say var get last token ID. There you go. Then later, when we start minting and creating new tokens, we'll have to increment that number, right? So right now, this number is not going to be the right number because we already instantiate one here with U1, but we'll figure that out in a bit. Then the next step is get token URI. So this can be another read-only function. And this is, again, like the equivalent function in ESC 721, where you can return a link that points to a file with metadata information about the token, right? Which is usually like a JSON file or something. So if you have a digital piece of art, it would list the name of the author, it would list where the actual image file is, right? Things like that. So this is the equivalent function for that. So get token URI. And if we take a very quick peek at the SIP standard about the token URI, so it takes an identifier and then it returns a valid URI with metadata. So we have to return that based on whether that NFT actually exists. So it can either return an OK none if there's no link, or it can return an actual link. So since, for example, here we don't have a link, I'm simply going to return OK none and skip over that. So this gives us an interesting pattern here. So this is the first thing that that you'll come across when you're writing your own contracts in Clarity, is that you have to deal with a return type that is either an OK or an error right here. And you can fill in something here. So this is just a read-only function, so it's not going to change the chain state. But as you will dive into Clarity more, the type that is returned from public functions actually determine whether a change on the chain materializes or if it doesn't. So this public function right here, this works because this NFT mint, as we just saw in the documentation, returns an OK or an error type. So this function, this expression being the last one in this function, will return that response to whoever's calling the mint function. So if this returns an OK, then the chain state is changed, it materializes. If it returns an error, it does not. So in this case, this is the way in which you write your own return type. Okay, then the next one is going to be get owner. And again, we have another read-only function, and we can just call into the built-in function to actually get the owner, right? So we have a get owner, but we also have to accept a uint right here. So if we look at owner, as you can see, there's a uint. So you pass in an NFT identifier, and then it returns a response with who the owner is. So I have to specify a parameter here. So for clarity, you do it a little like this. So we say token ID, this is the variable name, and the type is going to be uint. So name comes first and type comes after. And you can see that this is part of the function signature, which is this first parameter right here. So I open this function up right here, and I say NFT get owner. The asset name is Marvin token. The asset identifier is token ID. And there you go, I'm done. I implemented this function as well. Oh, and then I just noticed that obviously I'm supposed to also have a token ID for get token Uri. So let's fit that in here, but it remains unused. We do have to specify it because otherwise we won't actually implement this trade. Maybe we can take something out and we can see that happen. Okay, then our final function is transfer. So obviously this is going to mutate the chain, right? It's going to change the chain state. So this has to be a public function instead. Well, we call this transfer. And then we have to look at the pattern here. So we pass in the U in first, which is the token ID. Right? When in doubt, we can just check the specification here. So U in principal, and it specifies the token ID. And let's see, let's return a callable. Yeah, and the first one is the sender. So this principal is the sender, and this principal is the recipient. So we can just use those names because it's easier to read. Sender, principal, and recipient. Recipient, principal. There you go. So we have NFT transfer. The asset name is Marvin token. The asset identifier is token ID. The sender is sender, and recipient is recipient. So there you go. Very basic implementation of NFT in Clarity. Any questions up until this point? I know that the syntax looks very foreign, but I hope that you're starting to get a feel for how that goes together.
Yeah, how does it know what in like the sender, who the sender and recipient is, or like what mint is in line 18? Like how does it know what mint is? Like where is that reference?
Right, you mean right here, this function mint, and how does it know who the sender is?
No, how does it? Well, firstly, how does it know what mint is for that? Like where does mint come from?
Mm-hmm. Okay, yeah, so this mint function here is a custom function that I define called mint. So this is not part of the trade, as you can see. So this is kind of like a helper function for me to test it out. Then NFT mint is a built-in Clarity function. So this is a public function that the outside can just call into. So yeah, we're going to try that out just right after this. Any other questions on what I've done so far?
Oh, so when you deploy this, or when you test it, you're gonna like put all the parameters for everything. Oh, okay.
Yeah, exactly. I'm going to call into yeah, exactly. Okay, so now that I've written this very basic contract, we can check if it properly implements this trade. So let's see if I did it right. So with Clarinet, we just type Clarinet check, and this is going to do our analysis of all the files. So I'm going to do Clarinet check. And then I see that I actually get an analysis error. It says an invalid signature from method getLast token ID regarding the trade specification. So I messed up getLast token ID here. And I'll have to take a look at the specification here. So getLast token ID, it takes no parameters, and the output parameter is supposed to be a response. So it has to be an okay or an error. And when I look at this, that's not actually what I do. I return my variable as a uint. So my mistake here is that I have to wrap this in an okay, it went well response. So let's try this again. And there you go, another typo here, get owner. It's probably going to be the same issue, get owner, NFT get owner. I return a response with an optional principal. Okay, so same thing here, wrap it in an okay. All right, Clarinet says nothing. That means that it's happy. Okay, so let's try out this basic contract first, and then we'll add some more changes to it to actually make it more easy to use. So Clarity allows you to actually start a local chain with a console where you can just run contract calls directly, which is very exciting and very easy to use. So I just typed Clarinet console. I'll do it again. So I type Clarinet console, and you can see it spits out a bunch of information. And it gives us a list of all the contracts that we have deployed. So you see that there's two. We have Marvin token that's deployed, and we have NFT trade that's deployed. And it also initializes a bunch of wallets for us to use and to test. So going back to Truffle once more, you have your Truffle test files, right? And it passes in a list of wallet addresses that you can use, right, with test tokens. So that's the exact same. It also shows us all the public functions of these contracts. So you can see the trade has nothing because it's just a trade contract. And then the Marvin token has the function that we define right here. So taking a look at this, let's start here. We see that we have the deployer and we have a bunch of wallets. And this is what a Stax address looks like. So on testnet, it starts with ST. Mainnet starts with SP. And then we have an address in a format that looks like this. Looking at the contracts, however, we see that the contracts actually have a readable name. So this is different from Ethereum, where Ethereum also just have their own, address space. And if you look at an address, you can't really tell if this is a standard principle or contract principle. In Clarity, this is very distinct. They have a readable name that you can refer to. I think that's very useful. So what do we see here is that this address has deployed two different contracts. So the NFT trade is deployed on this address and also Marvin token. So what is this address? Well, in this case, it's the deployer address, as you can see right here. So that means that if you deploy a contract from your own wallet, it's going to be deployed in the same fashion. So say that this is your address, you deploy a contract. Your contract is going to deploy it sort of as a subsection of your address, which is a different model, but I think very interesting. So let's copy this address right here, because that's what we're going to use. And let's try to contract call into some of these functions. So we'll start with mint. This is a public function that is just going to mint a Marvin token with ID 1 to the transaction sender. The transaction sender being the same as message.sender in Ethereum, right? We have TX sender instead. So if I type that, you can see that currently I'm also this first address, I'm the deployer, but I could switch to any of these wallets if I want to. So since this is a actual console environment, I can type Clarity code in here. So if I can give you a quick example, I could run a increment function, and I can calculate stuff in here. So if I want to do a contract call, I use the contract call function to get that done. So contract call, the first parameter it takes is the principal of a contract. So principal starts with a single quote, and then you get the address dot the contract name. Then it's followed by the function I want to call, the function name I want to call. So in this case, mint. So I can do this contract call, and you can see that I receive a okay true, so it went well. And then also in gray, I see that there was an event that was emitted. The type is an NFT mint event. It gives me an asset identifier and a structure that's not very important right now. We have a recipient, which is me, and we have that value, as you can see, token identifier U1. So earlier, someone asked, my apologies, I forgot who, but like what happens if you try to mint that again? Well, we can try that out right now. So let's call the mint function again. We get an error U1, which, as we saw on the documentation, means that the asset identifier already exists. So this is great. We already have these guards built in. We don't have to deal with that ourselves. That's fantastic. So, and then another question that was asked just on voice chat is like, well, then how do we specify these different parameters? And this is exactly as was concluded, like we do this in the actual contract call, right? So let's see if we can call the transfer function to transfer that token that we just minted. So the transfer function takes the token ID, which in our case is U1. Then we have to put in the sender. Well, the sender is me, it's just myself. So I can use that keyword TX sender. And the recipient, well, let's just pick any of these wallets. Let's pick wallet number 8. Why not? So principal starts with a single quote. I put that in here and I hit enter. And you can see I get an OK true. OK trues are good. And an event was emitted, an NFT transfer event from sender, which is me, to recipient, which is this wallet number 8. And then this token ID U1 was transferred. So that's great. And I think very, very easy. We build our own NFT in just a couple of minutes. We can check this in the console in a very, very easy way because the console has a few kind of built-in helper functions that give you some information about the chain state. So the one we're interested in here is called get assets maps. It gives us a list of all the assets currently being held. So the asset map is what you see right here, but we can get a updated one, get assets maps. And going through that, we see that the asset map has been updated and now contains a column for Marvin token. And that's because we minted our first ever Marvin token, right? So now this is materialized on chain and seen on chain. So we see that all of these principals have 0 Marvin tokens, except for, of course, wallet number 8, the one I just transferred it to. So we'll try this once more, but now we'll try to transfer it from this wallet number 8. So we're going to change our transaction sender to that principal. So we're going to say set TX sender. I'm going to paste in this number 8. And let's bring back this contract call that we did before right here. So I'm going to call it again, but now I'm going to call it as if I'm that wallet number 8, right? So let's send it to, let's actually do something funny. We could also send it to the contract itself, because contracts can also hold NFTs. So let's find the contract address here, right here, and give the contract its own NFT, because why not? That should be possible. So we have the extender. We pass it in here. We do a transfer. It says okay, true. Just to verify which the extender I am. Yep, that's the one I just passed in, right? And we can do get assets maps. And we'll see that the contract now holds 1 Marvin token. And now it's stuck there because the contract cannot really send it out to anyone. There's no provision for that. But you can do that because they're all first order citizens on the Stax chain. So they can also hold NFTs and fungible tokens and Stax tokens. All right. So there's one more thing we got to do here before we are ready to deploy this contract. And that's we have to deal with this last token ID here. Because right now this is always U0. So if I call into that, so let's quickly go back here and do a contract call, right, to that contract here. So we contract call get last token ID, right? We're going to get U0. And even if I mint, right, so I'm going to call the mint function. It's going to mint that first token, and I do get last token ID. It's still going to be U0, right? We never do anything with it. So that's the last thing that we got to change. We got to increment this. So we'll change up this mint function a little bit in a way that anyone can just call this and they just get the next token ID minted to them. So that could be kind of a fun thing to do. So we'll change this up a little bit. So let's take this out. Actually, let's leave this here, and I'll show you the issue that we're going to have is, say we want to update this last token ID to a different value. Let's do hard coded for now. You can see that the function is now red underlined, and it's saying expecting 2 arguments. We've got 3. So the thing is that every single expression here is also a function in itself. So define public is a function that defines a public function for our contract. And define public as a function only takes 2 parameters. So it takes a function signature, which is the name of the function, and then it takes the function body, which again is 1 parameter. But right now I'm passing it 3 parameters. So if you count, we have mint, that's 1. Then we have this one, which is 2, and then this var set, which is 3. So this is just not going to work. So what you usually got to do is you have to pass in a expression that allows for just a variadic amount of expressions. So in Clarity, we have an expression called begin, and begin executes all expressions in sequence and will return the result of the last one. So that might sound a little complicated, but in essence, this is what this comes down to. So if I do this begin, then I can have multiple expressions in the function body. Okay, so let's move this like that. And now you can see that the mint function is fine. So what we want to do is get this token ID and then increment it after, and then update the new number, right? So easiest way to do that is to define a local variable in this function. So you can do that with a let expression. So just like begin, let allows you to have multiple parameters or multiple expressions in sequence, and it will return the result of the last one. So for let, you define a variable that we'll call token ID, which is going to be equal to var get last token ID. So taking a look at this, let takes a list of variables. So I can define multiple variables here if I like. Here's another one, right? Give this a number like this, and you can just have an expression here per variable, and you can define multiple variables. So that's what that structure looks like. This is just a list that contains variable definitions, and then it contains the actual body of the function, if you will. So we have one variable, token ID, which is going to be equal to the last token ID that we saved here. Then we want to do a NFT mint here, right? And instead of hard coding that in here, we're going to just put that token ID in here. And then obviously we also want to update this last token ID variable with the new ID, right? So we can set this equal to increment token ID by U1. So again, if you use to a different language, this might look a little funky to you because normally you write something like token ID +1, right? So you have an infix operator right here, which is addition or increment or whatever you want to call it. So in Clarity, since the only thing we have is these expressions that all have their round braces, increment is just like a function. So it's just a function with a name that is the plus sign. So you shouldn't read this as anything special. You could also equivalent this to something like token ID U1. So you say add these two numbers together. So that's what's happening here. So we say var set the last token ID equivalent to token ID +1. That's what this says. Then we do. Sorry, go ahead.
You can just apply like functions as like the parentheses next to like an integer, like that.
Yep.
Oh,
yep.
Shit.
So you have to see, like, this is an expression. This is a function call that takes two unsigned integer inputs and returns an unsigned integer input. So I say increment token ID, which is a uint, right here, and add a U1 to it. So I can do this in the console down there. I can say increment, U1 and then U5, and I get U6, right? But I can wrap those again. So I can say like wrap these and then add another number to it, maybe like do this, like plus U5, right? And you get U11. So you can construct these interesting setups like this. All right, so here's a new mint function. I define a variable token ID, which I read. Then I do a var set last token ID, which I increment token ID by 1. And then I NFT mint the token ID variable. So that's this one right here. And NFT mint is going to return that OK or an error. So this function should be OK. So let's try that out. We can exit out of this. There you go. Console. Just making sure, yep, my contract's still deployed. And I know we're a little bit over time, but we're almost there. So the contract call to our Marvin token, we call the mint function. And let's see what happens. It says, OK, true. And it minted a token with ID 1. Let's call it again. It says, OK, true. And we can see a token with ID 2 and 3 and 4. And as you can see, we can keep going. And let's check our asset maps, get assets maps. Let's hope that this shows up properly. Okay, well, this is a little visual glitch in Clarinet. Sometimes it shows a really crazy number. Probably it has its own overflow. Who knows what's going on here? So I'll have to bear with that a little bit. But, I have a few of these tokens. Let's switch to wallet number 2. So txender. And let's call the mint function. All right, so we see that token number 8 was just minted. Get the asset maps, and we see that wallet number 2 also has a Marvin token right now. Okay, so this is a very basic implementation of your own SIP9 compatible NFT. So SIP9 is important here because it's just like in ERC 721, right? If you want to have that interoperability between different contracts, so there's marketplaces and things like that that support SIP9 tokens. This is what you want to do.
How you
All right. Any questions about this? Next thing we're going to do is deploy, but any questions about the contract itself?
how do you like actually add like an image like from like an IPFS or like the actual like art or like the data associated with like an NFT?
Yeah, that's a good question. So we have this get token URI, right? So if you do an ERC 721, what you would do is you have a metadata file that you link to that contains that information, right? So that's the same thing you would do here. So instead of having that okay none, you could return a string ASCII with that information that points to that, right? So you could say you said IPFS, right? And you could have that link in there with that information. So you would specify that somewhere else here in an okay. Does that make sense?
Yeah.
Cool. Yeah, sadly we don't have the time to go through all of that, but that's where you would put that information. Okay, so let's deploy this thing and let's revisit the trade. So we have implemented this trade successfully, and we can verify that with Clarinet check, as we've also seen. I actually already made some mistakes and I had to fix that. So Clarinet check, now it says nothing. But say if I take out a parameter, or I don't know, let's change this name. Let's add a keyword there, temporary. I get an analysis, our invalid signature get token URI regarding the trade specification, right? So this already makes that explicit. So if I want to have this deployed, this contract, I would have to do two things. I would have to deploy the trade, and then I would have to refer to the trade. But since this trade can already be pre-deployed and just exist on mainnet or on testnet, I can also refer to that externally. So that's usually what you want to do. Since this trade is defined in this SIP, if we go all the way down, we can see that a trade that follows the specification is actually already on mainnet deployed on a specific address right here. So let's take a quick look at the Explorer, which I should have here. Right, we can see that this version of the NFT trade was deployed 4 months ago, and we can see the actual source code. So this is exactly what exists on chain. I told you before, Clarity is interpreted, it's not compiled. So this is one-to-one deployed on chain. So what you want to do is, if you want to deploy your own NFT on mainnet, it's a lot easier to just refer to this contract because it already exists here. So you can see the contract name exists right here. I can copy that. Let's see if this is also specified. Yep, the trade is right here. So I could copy this trade definition here and put this in my implement trade. So instead of referring to this local trade that I just copied, I will say implement trade, and I specify the entire trade like this. And now I can just deploy this on mainnet as is, and it will deploy. Okay, so let's deploy this on testnet, and then we're gonna call it a day. So very easy way to deploy stuff on Stax is just by using the Explorer. So the Explorer has a section up here. It doesn't stand out very well, but the Sandbox allows you to interact with any Clarity smart contract, but also allows you to deploy contracts quite easily. So you can see write and deploy. I can write, it should have autocomplete, doesn't it? Oh, there you go. So you can actually write your own code here and deploy it as a contract right away. So right now I should be on testnet. Let me just double check. Yes, I'm on testnet. You can switch networks right here, and you can deploy a contract right here. So before I do, I'll just quickly click through this. So here you can do a contract call. You can send stacks, and there's also a faucet. So if you want to test it out, you can request stacks and it'll send you a bunch of tokens. Right. Failed to fetch. Oh, there you go. I was just going to say, so I got a transfer Stax incoming. Okay, so since we're deploying on testnet, I'm going to remove this reference to the trade right here because it won't work, because this is pointing to a mainnet address. You know, it starts with SP, so this is a mainnet address. Since testnet was reset at some point, there is no, as far as I know, no NFT trade already deployed on testnet. So, you know, we could do that separately, but let's just leave this as is for now so that we can deploy this token. Okay, so let's just copy this. I paste it in here. So now you might say, like, well, if I remove that trade definition, that trade implementation line, doesn't that mean that my token no longer conforms to that trade? And it actually still does, because if we look at the functions here, it does implement all the functions. So what we've just done is we've gone from explicit conformity, where we actually assert like this contract implements this trade. We've gone to an implicit conformity. So I'll repeat that. It's now implicit instead of explicit, because if someone calls into this, or you pass this contract somewhere where it expects a SIP9 token, it can still, through static analysis, figure out that this contract does in fact conform to that trade. Normally, that's not what you want to do. You want to have that explicit definition in there, because then if you deploy, it will check it against that trade on deploy, and it will fail. The deploy will fail if it doesn't conform, right? But since we're on testnet right now, we'll just take that out. So, you know, I can give this an interesting name. I call this Marvin token. So let's also call this Marvin token. Why not? Right? We hit deploy. I have to enter my testnet wallet password. Wait for that to unlock. There you go. So you can see I can deploy a contract on testnet. I can see the actual code of what I'm going to deploy, and I can hit confirm. And that's it. You can see Marvin token is now being deployed on testnet, pending, and the actual contract code can be found right here, exactly as we have written it. So that gives you an interesting side effect. If you write some comments in your code, those comments are going to be visible on chain. So that's something you got to keep in mind, depending on how, you know, the kind of code that you write. All right, so this might take a few minutes to complete. Once it is deployed, you could go to this section right here, and you could paste in the contract address, and you can interact with it. So you know, let's hope that after our question round, it's deployed, and we can try that out. But otherwise, yeah, we're going to end it here. All right. A lot of info in a short amount of time, but we managed to deploy our own NFT on the Stax chain, secured by Bitcoin, in a little over an hour. So I think that's pretty good. So the Bitcoin stuff, just to quickly show you, here's the NFT trade that was deployed earlier. We can see that the Bitcoin anchor is in this particular Bitcoin block, and we have the Bitcoin block hash right here, and we can click on that, and it'll bring us to Bitcoin Blockchain Explorer, and it'll show you the actual block and transaction that included this contract deploy. Yeah, so you can see right here. Yep. All right, so any questions?
There was a question that was like asking like if you can make trades and your own standards, really.
Yeah, Tristan, I just saw it in the chat. So theoretically, we can make trades and our own standards. Yeah, that's exactly true. And we're only scratching the surface of trades here. So I just showed you a SIP9 trade, but the important bit here is that this is a composition model, right? So a contract can implement more than just one trade. So you could define these custom trades that are then implemented by your own contracts, right? Say you come up with a DEX idea or marketplace, you can define a trade, and then you can implement this trade to have that interoperability, but then you can also suggest this as a SIP and have this become a standard, so all the people conform to it. But yeah, you can definitely just write your own trades with your own standards. Any other questions?
How many people like are kind of Clarity devs, would you say, at this point?
How many people? I couldn't say. There's a bunch. Maybe Jenny would have a better handle on that because she does a lot of the community outreach, but we have a really strong like core group of community members that have been working on this for a long time. So there's a few folks out there. Like I said, Freaker just did a Bitcoin swap. And then we have a bunch of people working on like liquidity pools and something like Uniswap. So there's a product called Swapper that's being built. And those are like the core community members working on those things. But I think all in all, yeah, Jenny, how many we have here? Is Jenny still in here? I can't say, but there should be like 50 to 100 at least. But that is also something. So there is an extreme demand in Clarity developers right now, and we cannot meet the supply. So anyone that's interested should definitely jump on that as well. Any other questions?
That was pretty clean. Like the language was clean, the UI was clean. Like everything about this is clean. It's pretty. So I'm trying to explore. So what would be kind of the next steps in the development like that? Like after this, like if you were to like develop a roadmap to being like a Clarity dev, like what's the usual, like what you learn?
That's a good question, and actually really ties into my closing statement. Is so if this interested you and you like Clarity, and like I said, so there's a real beauty to working in Clarity once you get the hang of it. Like, you'll be fighting a language like you would any new language, but once you sort of like get into it, there's a real beauty to that simplicity. And this is coming from someone like I myself had been a Solidity developer for many years, and I would never go back to Solidity if I don't have to. Like that's how different this was for me. So if this interested you, we are actually working on a project right now that we call Clarity Universe, which is going to be a 6-week cohort where you will learn Clarity and you will work with a lot of people very influential in the scene, but also not a lot of other passionate folks that want to jump on the smart contract bandwagon, but want to do something different. So if that sounds interesting to you, I press you to check out Clarity Universe. So we have a wait list right now. This is going to be free. Anyone can join. We'll have a lot of sessions like these, but a little more structured. We'll go through it more slowly and we'll discuss, and there's a chance for questions. We're producing a book on Clarity that will also be free for anyone to access and to use, with interactive snippets, and it'll have curated contracts, and you can work through all of that. And at the end of this cohort, we also will provide a pathway for people to actually start building on Stax and get the resources and the funding to do so. So at the Stax Foundation, we have the grants program, which if you have an idea that moves forward this mission of the user-owned internet, because that's what it's all about, the user-owned internet, if you have an idea, you can apply for funding with the Stax Foundation. And this is very open-ended and pretty much like a very good deal. Once we figure out the deliverables, it should be open source, but then you just get funded to build what you want to build, what you're passionate about. If you want to go beyond that and you have a group of people, you have a team, and you're all very passionate about something that you want to build, say you came up with the next DeFi protocol, right? And you need not just funding, but like the resources and the connections and the mentorship to make that possible. We also have the Stax Accelerator. So you go in there, you get 50 grand right off the bat. You can start building, and there's mentors like Sergey from Chainlink. We have Muneeb Ali from Hero, and Melton Demirs, and all sorts of like people of that caliber ready to help you out. Anthony Pompliano as well, by the way. So yeah, that's a lot of stuff you can check out. I see a question here: how can I join Clarity Universe? So you can go to the link on screen right now and sign up for the waitlist, and we'll send out an email very shortly. And yeah, we hope to see you there. Cool. Yeah. So any closing thoughts from anyone? Maybe we can see if our token has deployed yet. Okay, Marvin token has been confirmed, as you can see. So let's try this out as a little like close off thing. We'll copy the contract link here, and we'll go to call a contract. We'll paste in the link, Marvin token get contract. Let's unfold this. All right, here are our functions. So let's call mint, call function, confirm. Right, and you can see how nice even this interface is just to interact with your contracts directly. So we obviously didn't get a chance to talk about building a app that interacts with it, you know, like just like you would with MetaMask. But that would be the next step. So we have a lot of libraries available in JavaScript to make that very easy for you. So this is just called stax.js. That's the version, that's our web3.js, if you will. So I'll call this function here, call the mint function. And you can see that's running. So there you go. I called mint. This is going to mint that token. We already know this is going to work because we tested this in our local chain, right? So this is going to work out. So yeah, that's it. Thank you so much for your attention. I know we went over time a little bit, but you know, the project of just doing an NFT, I think that's still pretty impressive that we got that done in a little over an hour.